All right, let's begin our webinar. So, hello everyone. My name is Johannes Nyman, and I'll be keeping this webinar about geocomputing in the Puhti supercomputer. And first of all, you should know that this will be recorded and published in YouTube. So if you have colleagues or someone that couldn't attend, you can maybe hint that this might end up in YouTube as well. And if you have any questions related to these, feel free to put them in the chat window. I will go through them after the presentation. So, geocomputing in Puhti supercomputer. There are some reasons why you might have to do this, and here are some of them. So maybe you have some analysis that takes a long time on your laptop or workstation. So let's say if it takes more than 2 or 4 hours and it takes all your computing power, it's quite inefficient to run on your laptop. So it's a great situation to actually use our computing services. Also, often you might have so much data, very big data sets, satellite images, LiDAR data for whole Finland, whatever. It may be a problem to store that data in your computer or wherever. And if it's a really large data set, it needs also quite a lot of computer memory to actually be able to do something for it. Also, if you have just some really long analysis that take like a week or something, and you don't want to keep your laptop open for a week in a row, it's a good idea to outsource it to CSC. Also, if you need a server for your research or some other purpose, we have this virtual machine cloud, and that's the best place to get one of those. If you have a course, you're keeping a course and it involves coding in some way, you can use our notebooks service, which means that every student gets their own notebook environment where to do their exercises and so on. Also, we have on our Puhti supercomputer a lot of pre-installed software and also data locally. So it's convenient to use them if they're, for instance, difficult to install or you can't install them due to strict IT policies or something like that. And maybe the biggest reason you should use maybe CSC services or computing resources, it's free for all Finnish university and state research institute users, as long as it's open science and or education. So we have basically made two relevant computing services for GIS users. There's a lot more, but these might be or are the most relevant to GIS users. So Puhti, the supercomputer I'll talk a lot about today, and the cPouta virtual machine cloud. I won't be talking about Pouta that much, but I'll mention it that it's an option if you need your own machine and you want to install your own software and not worry about queuing in Puhti and so on. The downside to Pouta is, of course, it's a single machine or a virtual machine basically, it doesn't have as much computing power as the supercomputer. So Puhti has pre-installed software, and you can also install something yourself. And Pouta has only user installed. So it's a clean slate, basically. You have to do everything yourself. Data sets. So I mentioned that Puhti has a lot of data already locally, which you can use all the main Finnish GIS datasets, basically. And the computing power, of course, is quite different. In Puhti, you could be able to have thousands of CPU cores and even several GPUs, graphical processing units, and even terabytes of memory. Of course, normally these are way too big numbers for any GIS users. So these are kind of the maximums. Pouta machines can be quite powerful as well, but also those maximum specifications you can see there start to be quite special cases, and maybe not the basic GIS users choice. In comparison, the average computer has 2 to 4 CPU cores and maybe 8 gigabytes memory. Okay, those were quite big numbers, but you should still really know this. We get this quite a lot, that users have transferred their scripts to Puhti and are wondering why they aren't any faster than on their own computer. And this is due to the fact that a single CPU core in Puhti is about as fast as one of your own in your laptop. So if your script uses only one CPU core, it won't get any faster in Puhti. The idea where the computing power comes from is quantity in Puhti. So Puhti has a lot of CPU cores. So if you know, or your program, whatever you're using, knows how to divide this computing, it can utilize Puhti. And if it scales really well, it can utilize it even like to hundreds or thousands of cores, which is a lot. Also, Puhti is, of course, optimized for computing. So all the disk areas and storage areas and networks are as fast as they can be, basically. So if you need to download big amounts of data, it's probably the internet connection in Puhti is quite a lot faster than your own, or transfer a lot of data, or write or read. All of those should be faster in Puhti. So that was pretty much about having realistic expectations of Puhti. And especially the GIS users, it's all about the data. Usually the calculations and computations are demanding because there's a lot of data. Varied satellite images, LiDAR data, aerial images, or some other global data sets, or even national data sets can be huge. So in CSC, we have, of course, some local storage on Puhti. So you have your own local storage, but it's not meant for all of your data. If we start to speak in tens or hundreds or thousands of gigabytes, it's better to keep it in our main file storage system called Allas. And Allas is this kind of data lake or object storage type of system, so very similar than what Amazon and Azure, Microsoft's Azure has available. This is only one slide about Allas. I've held a webinar in last June about Allas, and it can be found in YouTube. So it's a good idea to dive into that from maybe the previous webinar. Shortly, it's a good thing to mention that the data can be shared easily from Allas. You already maybe downloaded these slides. They are from Allas. You get a link similar to that then, and can share publicly or then just share between your project's members. And one important thing maybe is that the data in Allas is immutable. So it basically means that you can't use the data from Allas. You always have to copy the data from Allas to Puhti, let's say, or somewhere else, and use it in Puhti and store the results back in Allas. So it's more like a real storage that you have to put your files and get your files every time. But now maybe to the topic at hand, Puhti supercomputer and geocomputing with it. But basically Puhti. So Puhti is a bit over a year old, and it is located in Kajaani in this data center, CSC data center that hosts almost all of our computing services. And it's in an old paper factory. And then maybe the interesting part is here that it uses 100% renewable energy and cools itself with the water from the nearby lake. And other supercomputers that are residing in the same address are Mahti, which is the big brother of Puhti. And Mahti is only a month old, maybe. But Mahti isn't relevant to GIS users as it does not have GIS software installed. It's mostly reserved for like enormous computations, and we're talking about quantum physics and that sort of stuff. So until GIS evolves into a field of science that uses thousands of cores daily, there's no need to install GIS software in Mahti. Puhti is enough. Also in early 2021, there will be LUMI, which is this European project with, I believe, 9 countries, or is it maybe 10 now, funding it. And it will also be located in Kajaani, and it will be one of the absolute fastest supercomputers in the world. Maybe top 5, top 3 when it's launched. It might have GIS software, it's still a bit unclear. But the point is that there's plenty of supercomputers in Kajaani, and plans are underway to use the waste heat to actually heat the city of Kajaani, which would make the data center net negative in carbon emissions. It's pretty cool. But the technical parts, the first part of the slide, I didn't say anything. Well, Puhti, it's called a supercomputer, but in essence, it's more of like a cluster of computers. You could say it has 682 nodes, and node can be thought as a computer that you could take home or something like that. So it has almost 700 CPU nodes and 80 GPU nodes, which is graphical processing unit. One node has 40 CPU cores, so it's quite an powerful one. even one, and one GPU node has 4 of those state-of-the-art GPUs at the moment. Altogether, Puhti has 27,000 CPU cores. When it was launched, or near before when it was launched, it was 160th fastest supercomputer. I think it was the fastest in the Nordic countries back then. And now it's already probably like 300 or something. The pace of development in supercomputers is really, really insanely fast. But the keys to actually start working with Puhti or any other computing environment is to actually get rid of the graphical user interfaces that we all love, QGIS, ArcGIS, and they are still great for doing preliminary work and displaying results and that sort of stuff. But if you're doing hard computing, you have to find a way to have it on a script. Two most popular scripting languages that GIS users and maybe other computing users as well use are Python and R. And I would say it's something maybe 50-50. So they're pretty close in popularity. So basically everything that QGIS does, you can do it in a script. Even the tools are, well, you could use the QGIS tools, but even the tools are built on libraries that you can use, like GDAL. Also, of course, you don't have to run Python or R if you have a ready-made program that you can run in Puhti. We have installed, I'll show you a list. And you can run those with normal shell commands, basically. So if your program is not listed in here, you can ask us to install it if it's possible to install in a Linux environment. And you can use it in Puhti. So this is the list of current software in Puhti. We have pretty much tried to install everything that we might think of or that anyone has asked for us. So if you figure out or you have some kind of a program you need, which is possible to install in Linux, we can try at least to install it in Puhti. Shortly, I could say that force and splits are Sentinel image downloading and manipulating and analysis software. It's used by Finnish researchers. GDAL is maybe the most famous of all of these because it's basically the fundamental library that I could believe almost all of these other programs use. So if you're clipping rasters or calculating something with rasters or doing vector stuff, all the programs you're doing it with uses GDAL in the under the hood, and you can use it yourself, and it's a really good skill to have. LustTools is LiDAR stuff. Also, actually, the X tools work, even though that they're Windows environment. Maybe other things to mention, OpenDroneMap. So if you have drone data, you're doing some kind of photogrammetric point clouds, it's possible to use OpenDroneMap in Puhti. Well, we have a ton of GIS packages for Python installed, and I won't go through them all. There's probably tens and tens, if not even over 100. And QGIS is actually installed in Puhti. and there are very limited capabilities of using a graphical user interface in Puhti. It is possible, but it's slow and kind of a pain in the ass if you're used to doing it on your own laptop. But basically, you could view your results, for instance, in Puhti as well, without transferring the data to your computer. Then we have R packages as well. We have SagaGIS, Solaris, which is a deep learning GIS library. And also somewhat popular is the SNAP, which is the European Space Agency's program environment where you can do different kind of corrections and manipulations of Sentinel satellite imagery and other as well. And it works pretty well in Puhti. Maybe those are the most popular. So, like I said before, if the computation does not know how to use several CPU cores, it's not any faster in Puhti as your computer. So in general, what kind of things are parallel? Well, Python and R are maybe the easiest or the straightforward to make things run parallel. Then Snap, which I mentioned, knows how to calculate the satellite image stuff in parallel. SagaGIS has some tools that use parallel computing, but it's quite vague as which ones are and which ones aren't. Then if you're used ArcGIS or ArcGIS Pro, well, Pro starts to have some tools that can utilize several cores. But like I said, it's not in Puhti. And GRASS as well. It's also not in Puhti, but if there's anyone that really wants GRASS, I think nowadays it could be possible to install. It was pretty difficult a year ago. And Python and R have these parallel libraries that can be used to actually making the computation parallel. These are just maybe the most popular and the simplest. We have example scripts from these as well, so you don't have to maybe figure out them all by yourself. And to highlight again, some GIS software are not possible in Puhti. Like I said, Windows software, no ArcGIS, server software, so Puhti is not the place for GeoServer or MapServer. Pouta might be if it's a possibility. Also, you shouldn't use Puhti for databases as it's not meant for it. Also, Pouta might be the case here. Of course, some programs have databases like built into them, or they use their own databases inside them all the time, and that's fine, but not for your database. So you should have PostGIS or MongoDB or whatever you have somewhere else, maybe Pouta. And of course, web libraries maybe are not very suitable for Puhti, or there's no sense of developing them there. So I mentioned about the local data in Puhti. So the idea is that we are hosting maybe most of the publicly available GIS data in Puhti locally. So if you need to use, let's say, the digital elevation model of the whole Finland, you don't have to transfer it there, it's already there. Currently, Puhti has over 11 terabytes of data, It includes all PyTuli data, and PyTuli is the data sharing or data downloading service that we have. It usually is familiar to people, but go ahead and check out if it's not. PyTuli has already most of that 11 terabytes, so these other ones are additional. So then there's some open data sets from Syke, Luke, NLS, and also some mosaics made from Sentinel and Landsat. There's Sentinel-1, so radar mosaics, and also NDVI and other indices mosaics made from whole of Finland. If there's a data set that you kind of think that you need in Puhti and other people might use as well, feel free to contact service desk, and it ends up to our work desk, and we'll look if it's possible to store it in Puhti. The GIS specific data is located in this path, Apple Data Geo. And all Puhti users have access to those, but only CSC personnel, which means me and Kylli, have write access basically. A few words about virtual rasters, as they are really, really useful in this sort of stuff. So they are one of these GDAL programs, kind of file types. They are in essence a catalog of files. So you might have, let's say, the digital elevation model files of whole Finland. There's thousands of them. And if you use some area from Finland, you would have to locate the certain files and clip them to your study area and so on. But with these virtual rasters, you can work with the data set as it was a single file. So just reference to this virtual raster file, and it will deal with the single thousands of individual files. Basically, it's just an XML file that has all the paths to the actual files. It's really useful and quite fast. And if you are thinking of having a lot of your own data in Allas, for instance, you could have one of these virtual rasters in Puhti, and it would reference the Allas files correctly as well. There's a slight speed penalty, of course, as it has to do it over the network, but it's still very doable. And also we have some Python code of creating these virtual rasters or using our own. So we have already made these for the DEMS, so digital elevation models. And I mentioned code. We have a Git repository. There's links in the slides, and maybe you can remember the geocomputing GitHub. I think that already you can find it from Google with that. We have different examples of R and Python with different those parallelization libraries, how to run them in Puhti and so on. I'll demo one of those today. And also these array jobs, which I will mention as well a bit later. We have examples of, then there's if you need to download Sentinel images, we have a script for that. And there's a snap example as well, and others that are not included in this list. So go and find that. There's also some of our course materials. We are keeping a machine learning and deep learning course related to GIS. So those materials are there too. So how to actually then utilize Puhti or start using Puhti? You need to have a CSC account and you need to have a CSC project. There's a ton of links here on how to actually create an account. There's the docs CSC FI is the documentation of basically all or most CSC services. And there's a detailed guides on how to create an account and project and so on. I will spoil it a bit. It happens in this mycsc.fi account management system. So basically you create an account if you with your Haka username. There's some other options as well, mostly Haka. And then you create a project, and your project has to have a manager that is like a PI for that project. And then you have to have a description and so on. But it's fast and simple in the end. Also, I suggest reading some basic documentation of Puhti, how to connect, for instance, from Windows, from whatever operating system you are using. How are the working directories managed? How the software actually, how do you run something in there? How do you submit a job to the queuing system I will talk about later. And also if you have a specific program you are going to use, it has a page with documentation on how to use it. And also, if you haven't ever used a Linux machine, don't be afraid, it's okay. You really need only the basic Linux commands to survive in Puhti. You don't have to be an expert on Linux, and most of the users aren't, maybe. So there's a Linux tutorial in docs, and of course there's a lot of tutorials in the internet as well. So basically all of these resources are controlled by billing units. This is sort of like a currency of CSC. So each project is given a certain amount of these billing units. There's like a default amount that you get when you create a project, and it's not a lot, but it gets you started. And after that, you can always apply for more billing units from the same service where you create the project. And if you apply for moderate amounts of billing units, you get them like with only short like description of your project and what kind of science maybe you're doing, what kind of papers might have come already about this and so on. You need only short description for small amounts of billing units, but if you start requesting millions, let's say you want to use plenty of GPUs for weeks or months, it costs quite a lot. So then you might have to actually explain a bit more than what you're doing and what is the impact and so on. But don't be afraid, you usually always get those billing units. Just apply for more when they start running out. So CSC resources consume these billing units. So if you use Puhti, you have a job that takes some time and uses some resources. So the more time it takes, the more resources it uses, the more it consumes these billing units. And like I mentioned, the GPUs consume a lot as they are really popular, they are really expensive to actually buy, and in general are in high demand. Also, storage uses building units as well. So it's not free to have some big data in Allas, or it actually is free for researchers, but in the terms of building units, it's not free. So Puhti has the default storage is free, but if you need an increased storage quota, then it is consuming building units. And also Allas consumes building units, but it's not usually that much unless you have several of terabytes of data. Yeah, the Puhti software is divided into modules. You can think that Puhti is maybe one computer. If you think of it like that. It has hundreds of users, so it's clear that all the software can't live in one environment. One researcher wants Python 2 and the other one Python 3, and so on. So the software is divided into modules. And these modules can be one program or a group of similar programs. It depends. And these basically load those applications so they are available for you. They adjust like path settings so your commands start working and the environment variables are correct. And for instance, to load one of these modules, if I would be doing some Python stuff, I would just write module load GeoConda, which is a module that has all of our Python libraries and so on. And it's a Conda environment, so that's why the name. And to actually know which modules to load, you can't know it unless you check the documentation. So docs.csc.fi and find your application and there it is. Like I said or mentioned briefly before, the Puhti is not a normal kind of computer. You have a queue. You have to queue for your jobs. So there's hundreds of researchers submitting jobs all the time, and there has to be a system that is managing all of those and in the most efficient way. So this batch job system is doing just that, and it's called Slurm, or the one that we have and plenty of other supercomputers have is Slarm. And you request some amounts of CPU cores or memory and time. So you have to kind of have an idea how long it will take, how much you should use CPU cores and memory, and so on. And it can be difficult to know those beforehand, but there's some guidelines and ways of figuring it out. And of course, sometimes it just try something and see what happens, basically. So sometimes you really can't know until you try. So there's a great graph about this. You have different jobs represented by these squares. The wider it is, the more CPUs it uses, and the taller it is, the more time is reserved for this job. So they are very different shapes. And on Puhti, we have these nodes, which are basically single computers, kind of. So one computer fits only 40 CPU cores, so it's a puzzle. The system has to build this puzzle all the time, so it's the most efficient way, in terms of resources. And always there's some downtime because the puzzle is impossible. I could say that Puhti has suffered from long queues until this autumn as the Mahti finally arrived. So now Puhti queues are very, very good, actually. The lowest they have been, I've seen them. So maybe like a hunch, I could say that if you reserve 10 cores CPU and maybe a few hours, you should get it running in a few hours. So it should stand in queue only maybe 1 hour or so. It could be it could be go running like immediately if there just is a free space for you, just your job. So you should always reserve like the minimum amount you actually need. Otherwise, you might end up queuing a bit longer. But in any way, like most of the, or in Puhti, there's 0.3 days worth of jobs in the queue right now. So if all the jobs, nobody would send any jobs, it would be empty the queue in 6 hours. That was a bad math, but let's continue. So how do you submit the job? You have to have a batch job script. It's a text file, very simple text file that ends with sh, which means it's a bash script. And this on the gray area is a very simple batch job script. With these sbatch notations, you request the amounts of resources you need. So basically this job would be now 2 hours. It requires 4 CPU cores and it wants 2 gigabytes of memory per CPU core, so 8 gigabytes. And the partition just means which kind of job it is. This is quite small, so it goes to the small partition, which is a synonym for a queue. So there's slightly different queues for different kind of jobs, but that all is in the documentation. Then actually the job, so we load the Gioconda module and run a Python script. That's it. So you submit this text file to the queuing system with the command sbatch. You cancel it with scancel and your job ID. I'll show you where you can see it. You can see your job information with SQ and U as username. And to know how much the actual job spent, or actually not spent, but used resources, you can see it afterwards with the ceph command. Very briefly, we have like a own course even for this, which is maybe once a year. But very briefly about these different kind of batch jobs. So basically these simple jobs are the ones that you have maybe ran on your own computer or somewhere. It uses only one core, so there's kind of like a one pipeline going forward. These array jobs are, I have a slide about them. They are a bit different. They are running at the same time. They have 2 jobs which are completely independent. They don't know anything about the other one. And it's an easy way to have parallel executions if you can just divide your work like this. Or then you have parallel jobs, which is basically one job, but it has several CPU cores doing the actual work. So inside the job, there's several parallel tasks. So maybe you read some satellite image, you divide it into 2, the other half goes here, the other half here, you do something to them over here, and then you write them somewhere, then you do some other thing, again with 2 CPU cores and write it out. So array jobs are maybe the simplest way of parallelization, just if the problem is easily divided. So in GIS terms, this would mean that usually users have vast amounts of input files. So map sheets, slider files, satellite images. So you could basically just have the one simple script that maybe uses only one core for each of these files and submit the job for each of the files. So they get sucked into the queuing system, and it gives them resources in the best possible way, and you end up with very easy parallel or parallelization. But the only thing that they have to be completely independent of each other, because they won't be running exactly the same time, probably. Other things, if you have different input variables or scenarios, this is a good one, or time periods, it's a good parallelization way or method. Often there has been problems if you write to the same file. So if all of these different jobs try to write results into the same file, I don't do it. It's not worth it. It's full of errors then. Reading might have some problems as well, but it often or most likely goes just fine. There's a link for the array jobs. This is quite a big topic as well, so I have to be brief now about it, but read more. Okay, if array jobs are not an option, then maybe the traditional parallel jobs are the way to go. So basically you submit one job, but it has a lot of resources, and you need to divide the workload for those resources yourself. So your script has to somehow give work for all of the CPU cores. And with Python and R, there's those libraries I've shown. If you don't use any of these and you just reserve 20 cores and submit the job, it will probably be done with only one core, and the 19 will be idling. Not good, not efficient. In GIS, you usually have one big data set and you divide it in the script, like, okay, that CPU core, you get 100,000 addresses and the other one gets 100,000 addresses and so on. They can be parts of a raster file or text inputs or whatever. And of course, there's the question, okay, if I can parallelize my script, how many of these workers should I have? So how many CPU cores? So let's say that you have a script that runs 50 minutes on one core on your laptop. If you give it 5 cores and you've done everything perfectly, it might take a bit more than 10 minutes. But you shouldn't really give it any more, because 10 minutes is already so low that it's not worth it anymore. So communication always takes time. The more CPU cores you have, the more kind of this extra time you get. So you should find a kind of efficient number of CPU cores for your parallel script. And maybe one guideline could be that if you have parallel tasks running, they shouldn't take less than 10 minutes. So it's not worth it if it takes less than 10 minutes. And these are really low numbers. Usually those take hours or could be days, depending how big it is. Okay, demo. What's the time? Oh, we are on time. Great. If you already saw or wondered about the moose in the slides, it's actually the symbol of Puhti, or the, I don't know, spirit animal. Mahti has a bear and Allas is a lake, I think. Okay, demo. Here I have a simple Python script. And this is actually the GitHub repository I showed you or mentioned earlier. So the geocomputing. And this script will be straight from there. I'll actually show you very quickly what it looks like. So yes, it exists. It exists. CSC training, geocomputing. There's Python, R, Snap, and so on. So this script, basically, I won't go to the code. It's not relevant here, but it calculates NDVI, so vegetation index for Sentinel images, and it takes input argument, which is the folder that has all the Sentinel images. And they are like the raw Sentinel images, the safe folders, if you have messed with them, you know. And it divides the work for 3 CPU cores. There's 3 images, 3 CPU cores, each one gets 1. Here is the batch job file, the sh ending one. It's a really simple. We choose to have one task, which means basically that one of those nodes will be doing our stuff. It will have 3 CPU cores and 4 gigabytes of memory, and the queue we're sending this to is test. One thing I have to change here, there's the account, there's the project that will be built, basically. So I'll insert one of my projects. And now I will demo that I actually transfer these files that are shown here to Puhti and run them. Okay, next window. I have here a FileZilla program, which I use to the file transfers. And if you're working with Windows and have a strict IT policy and so on, the comparison, the best kind of similar program is called WinSCP, or then you can use different sorts of transfer methods, but this is a really simple one. So I'll actually connect the Puhti right here. Like this. So the right side here is the Puhti file system, and the left side is my file system. And I have here actually opened already the directory. I have these scripts, and here I have my own user directory. So I have here a geocomputing demo directory, which is empty. Excellent. I'll just drag and drop them, okay, to the wrong folder. Another try. Now they're in the geocomputing demo folder. Okay, I'll connect the Puhti then. If you're a Windows user, you would use a program called Putti, not Puhti. There's a distinct there. And if you have some other program, you can use it as well. If you can install stuff yourself, I recommend Commander or some other terminal, but Putti is just fine. Okay, I'm inside Puhti supercomputer, and this is just the way you would do it as well. Okay, I have a folder, like I said, geocomputing demo. What's inside? Surprise, the Python and the bash file. If you're not, if you don't want to use the text editors in Puhti, you can do this, of course, in your local computer first and then transfer the files. I'll just see what this has. So I'll use Nano, which is one of those text editors. Okay, I remember to put the project, excellent. So then I'll just send the job, submitted batch job. Okay, now I'll test the different commands. Oh, you can see I already tested these earlier. Well, now the new one, which is this these 4 rows here. It always prints 4 rows with this sucked command, which I probably didn't have in the slides, but I had SQU and the username. It's the same, a bit different information. But this takes about a minute. So I'll show you actually some other commands in the meantime. So I mentioned the Ceph, which tells you the how the work actually utilized the different resources. So I had this previous job I ran actually today before this. So I'll print out that one. Okay, we can see I had 3 cores. The CPU cores were utilized about 3 minutes altogether, but the actual job took 1 minute and 35 seconds. So, and the efficiency for the CPU was 62.46. Okay, this is so simple job that most of the time goes to writing and reading, which is not parallel usually or ever. So we can see that this efficiency isn't that great, but it's still okay. I would say all the time have more than 50, but never less than 50. Then take less cores. Memory efficiency, the same thing. I reserved 12, used only 6.9. Well, there was some gigabytes of free space, but of course you should have a small reserve. So if you run out of memory, your job might actually be just killed. So you should have a few gigabytes of extra. Also, it tells you how much billing units you used. Okay, has it run? Excellent, completed everything. So now in this folder, I have a results folder that has emerged. And I can see that, okay, here are some Sentinel acronyms and file names. And in the end, I've actually renamed them NDVI. One thing still, every time you run a job, you get an output text file. So whatever you printed out or the program printed during execution, it's printed in out file, and by default it's this slurm starting file, but you can name it whatever you want in the batch job script. Let's see what this had. Okay, so all of these images went to the different CPU processors, and they are like doing it a bit out of sync of each other because they don't care what the other one does. So these are not in perfect order, but reading Sentinel image, computing and NDVI, saving, blah, blah, blah. Something like maybe I divided by 0 somewhere, or null values or something. Still worked, 64 seconds, excellent. That was it. As a summary, Puhti is an excellent tool for GIS users and you. If you need more computing power, surprise. If you don't want to run long analysis, you have a lot of data, you're using some of that big data that we already have locally, so it saves you time. You don't have to transfer terabytes of data. If you already have some skills using scripts or Linux, it's easy to just jump in. If you don't, you have to really study a bit, but don't be afraid, it's not that much. And if you're willing to learn, anything's possible. So thank you for my side. I will be looking at the questions in a moment. Here are some links. So if you have any problems with Puhti, Allas, or whatever, just contact Service Desk. They will know how to guide the ticket to me and Kylli if it's GIS related. There's more information in this research.csc.fi page in general geocomputing in Puhti and other places. The documentation I mentioned 1,000 times, and also the Git repository for the example codes is very useful. So let's see, I'll grab the chat window. I see Kylli has already answered quite a lot. I maybe try to reference them quickly. Okay, are we going to get a video link? Yes, or I don't know where it's shared, but it can be found in the CSC webinar page. Later, maybe, I don't know, days or week afterwards. It takes some editing. Yes, we will have the machine learning course Kylli mentioned. Batch job system or scripts can be used with any text editor, and there's plenty of examples in the docs csc.fi, and in the Git repository there's some GIS related as well. Is it possible to organize a practical session on the use of Puhti for my research group in my university? Very well, probably could be possible. Just contact us and we'll figure out. We have done similar things already previously. And if there's several people, it's of course better to have them in the same place. Interactive jobs in Puhti, yes, those are, I didn't mention anything about them, but they are a whole thing with RStudio server and Jupyter notebooks. You just can't do it interactively if you reserve a lot of resources, as you have to go to the queuing system. So you might end up having to do your Jupyter notebook things in the middle of the night. Okay, could you please zoom in? Oops, too late. You can use, how much memory and power can you use in interactive Puhti for R? Well, interactive session that starts right now, you can have only one CPU core and I think 16 gigabytes of memory. If you need more, and you probably usually do, you have to go to the queuing system. You can just queue like everyone else with their batch jobs, but afterwards the resources are allocated to you. You can start your session. Nowadays, if you reserve 4 cores or something, you might get the session in maybe half an hour, but that depends how much usage is in Puhti at the moment. Will ArcGIS Pro be available in the future? Also, would it be possible to run photogrammetry programs in Puhti? ArcGIS Pro won't be in Puhti until they make a Linux version out of it. So I could say never, maybe. And also the graphical user interfaces in Puhti, it's not the best place to use those. They are not meant for that. You should have maybe both a virtual machine and do it there. Photogrammetric software, well, there is the OpenDroneMap. If that is not enough, and you need Pix4D, I think is one, and Agisoft Metashape nowadays, I guess. They are also graphical user interfaces. If you can run them with scripts, then it's possible, and you can install them in Linux, then it's possible. If not, sadly, on Puhti, it will be difficult. Kylli helped with interactive work, ArcGIS Pro, excellent. And I think I ran all the questions now. So again, thank you all, and have a very nice year. I think we'll wrap this up. Thanks.